Hello everyone. Plan for today is to add and subtract radicals. Before this video, we've learned how to simplify radicals, which we'll use during this adding and subtracting. So just make sure you remember that. So first step, in order to add and subtract radicals, what's inside the radical has to be the same. Okay? So the problem I have written on the board, square root of 2 plus 3 square root of 2 plus 5 square root of 2, everything inside the radical is the same, so I can add them together. Okay? They have to be like terms. So when I add them together, I simply treat the number outside kind of like a coefficient. So we have 1 square root of 2 plus 3 more square roots of 2 plus 5 square roots of 2 gives me 9 square roots of 2. The number outside, the 1, the 3, the 5, simply acts like a coefficient. It tells me how many of those I have. Okay? Your turn. Try the next one. What if what's inside isn't the same? What if it's the square root of 50 plus the square root of 72? Now what? Well, now I got to make them the same. How do I do that? I simplify radicals. So what perfect square goes into 50? Well, I can break this down into 25 and 2. What about 72? Well, I can break that down into 36 and 2. Excuse me. Square root of 25 is 5. Square root of 36 is 6. Whoa, that was too much. Sorry. Square root of 36 is 6. The 2 stays alone. Now what's inside is the same. They're square roots of 2. And I end up with 11 square root of 2. All right, now try the next one. Cube root of 81 plus the cube root of 24. What do you get? Well, what perfect cube goes into 81? I can break that down into 27 and 3. What perfect cube goes into 24? Well, I can break that down into 8 and 3. Cube root of 27 is 3. The cube root of 8 is 2. And I have the 3 left alone inside. Notice what's inside the cube root now is the same. And I treat the number outside like a coefficient. And I have 5 cube roots of 3. As long as what's inside is the same, and the outside's a whole number, which we're going to talk about here in a second, or an integer, we are going to simply add the outside terms like coefficients. All right. What if we have some variables? Let's make it a little harder. Same thought process. I need what's inside to be the same. I've heard it explained sometimes you need to make the inside the same. Well, that's not a great explanation because you can't just make them the same. You simplify them and you see if they come out to be the same. If they don't come out to be the same, then you might be able to do some things to make them the same, but usually you're just stuck. Okay, so the goal is not to make them the same. The goal is to simplify and see if they come out to be the same. So 18, I deal with the number first. 18 breaks down into 9 and 2, and the x I can't do anything with, so I have 3 on the outside and the square root of 2x on the inside. 8, I can break down into 4 and 2, and I can't do anything with the x. So on the outside I get 2, on the inside I still have 2x. Well, what's on the inside is still the same, so I add them together just like I would normally. All right, try the next one. Reduce the inside. I might need more room for this. I'm going to get rid of this mess here. I'm going to get rid of all of this. I've already done the problem. I can slide this over. Whoops, lost the y. Let's slide all of it over. Okay, I'm going to do a bunch of rearranging. Let's get rid of this guy because This is going to take a little bit of space. All right. Sorry, a little rearranging. First thing, let's reduce, simplify these radicals. So I need to leave the y alone on the outside. I can break this x squared into x and the y squared into y. What is the square root of x squared? X. Leave the y alone. I don't know why I switched and put the x out in front. Have it. All right, next one. I can leave the x alone on the outside. I can break y cubed into y squared. Y squared times y. On the inside, or on the outside here, I leave that alone. The square root of x squared and the square root of y squared, y. All right, go back to this one here. X I leave alone. The square root of y squared is y, and the y I leave alone. Next one, the 3 I leave alone. The x squared becomes an x, the y squared becomes a y, and the inside I don't know. After that a little bit, square root of x squared becomes the x. Square root of y squared becomes the y. The square root of x squared becomes the x. The square root of y squared becomes the y. And the inside stuff gets left alone. All right. Notice what's on the outside. What's on the outside is not a nice, neat number, but it is a like term. I have 1 xy minus another xy plus 3 more xy. What's inside is all the same. They're all y's. So I can really treat these as coefficients in front. So I have 1 xy minus an xy gives me no xy, so that actually goes away. And my final answer is 3xy square root of y. All right, last one. This will make your brain hurt. Try that one. Remember, you can hit pause if you haven't already done so that you're not hearing my answer before you had time to start. All right, I'm going to break the 12 down. I'm going to break the x squared down. And I'll break the y squared down to perfect squares. Leave the 2y alone. 3 I can't do anything with. X cubed becomes x squared and x. Y squared is a perfect square. All right, let's work our way back. Square root of 4 I know is 2. Square root of x squared I know is x. The square root of y squared I know is, square root of y to the 4th is y squared. I don't know the 3, or I leave it alone, and the x. So we've done all of that. All right, next one. I have 2 I leave alone. I have a y I leave alone. Cube root, or square root of 3 I don't know. Square root of x squared is x. Square root of y squared is y. Well, I have another y now. And I have a 3 inside, and I have an x inside. Huh, that's a mess. Is what's outside by chance the same? Well, yeah. I can do some rearranging. Y times y is y squared, and I can switch the order around when you multiply. It doesn't matter what order you multiply in. So yeah, what's outside is the same. So I have 2x squared y, 2xy squareds on the outside, and I have, oops, I dropped my x, and I have 3x on the inside. So we can add like terms. These really are like terms. The fact that the 2's are the same doesn't make them like. If that was a 7, they would still be like. The fact that that is the same base with the same exponent, that's what makes them like. Okay, so this 2 could be anything. It just happens to be the same as the other 2. It does not have to be. It just happens to be. So 2 plus 2 is 4. So we have 4xy squareds on the outside, and leave the inside alone. The outside tells me how many square roots of 3x we have. The inside will not change when you add or subtract. Simply add or subtract the numbers that are out in front. All right. I think that's all of them. I thought I had a minus up there. We need to do at least one minus. Nope, I don't have a minus up there. Let's try a minus. So how about, wrong button. How about this? 3x y squared minus 48 x. Try that one. Give it a try, see what you come up with. 3 I can't do anything with. Square root of x can't do anything with. Square root of y squared is a perfect square, so I leave it alone. The y I'm going to leave alone. 16 is a perfect square that goes into 48. And the square root of x I leave alone. 3 again I leave alone. The y comes out. I have 4 that comes out to join the y. And the square root of 3x stays inside. Like terms, we have 1y minus 4y is a negative 3y. And what's underneath the radical is the same, so we are done. All right, that is simplifying radicals.